would explode and destroy all of New York City, parts of Connecticut and New Jersey. This is one of the greatest mysteries in all of physics.
Betelgeuse is a celestial marvel that graces the night sky with its presence. This iconic red supergiant, nestled in the Orion constellation, has captured the awe and imagination of stargazers for generations. However, recent observations and updates by the world-renowned physicist Michio Kaku have stirred concern. It is believed that Betelgeuse has finally exploded. How might this explosion of Betelgeuse reshape our understanding of stellar life cycles and the forces that shape our universe? What does it mean for humans? Stay tuned to find out. Imagine looking at the night sky and spotting a brilliant star in the Orion constellation. That star is Betelgeuse, also known as Alpha Orionis. Orion is a significant constellation in astronomy. It is positioned at approximately 5 hours 30 minutes right ascension and 0 degrees declination. It derives its name from the legendary Greek hunter in mythology. Recognized for its brightness, Orion boasts numerous prominent stars. Among these is Betelgeuse, a variable star known for its distinctive reddish hue. It ranks as the 11th brightest star globally, boasting a magnitude of 0.6. Notably, the brightest star in Orion is Betelgeuse. It's like a shining beacon on the hunter's shoulder. Betelgeuse comes from an Arabic word, bat al-jawza, meaning the giant's shoulder. So when you see this star, you're looking at the twinkling giant's shoulder in the sky. Alpha Orionis got its special name from an astronomer named Johann Bayer in 1603. Alpha means it's the brightest star in the Orion constellation. Interestingly, despite the star Rigel now being recognized as the brightest in Orion, Betelgeuse proudly holds on to its current name. Betelgeuse is a gigantic star. Its mass range is way bigger than our Sun, about 764 times bigger. Imagine if the Sun were a tiny marble. Betelgeuse would be a huge basketball. Figuring out how far Betelgeuse is has been a bit tricky. People think it's between 500 and 600 light-years away from our Sun. That's like a huge distance in cosmology. And when it comes to how bright it is, Betelgeuse is quite the shining star, with a super bright rating of about -6. Morgan McLeod, a researcher from Harvard University, explained that Betelgeuse is special because it's huge and not too far away. This makes it one of the few stars scientists can examine closely using telescopes on Earth and in space. So, it's like Betelgeuse is posing for a close-up picture for scientists to study. The images from these telescopes show that Betelgeuse differs significantly from our Sun's appearance. Instead of being a smooth and uniform sphere of extremely hot plasma, Betelgeuse appears as a collection of uneven boiling gas pockets, with some being quite sizable, comparable to small stars. Notably, large upwellings of hot material rise from the core to the surface of Betelgeuse. It's like Betelgeuse had some cosmic spring cleaning. One of these shells is so big that if you could travel at the speed of light, it would take you 7.5 years to go from one side to the other. These materials then cool down and return to the interior, reminiscent of the Sun's cycle but on a much more intense scale, almost like the Sun on an exaggerated dose of steroids. This cosmic cleansing done by Betelgeuse is what scientists call surface mass ejection, SME. Betelgeuse's surface mass ejections and the Sun's coronal mass ejections are similar. They both expel materials from their outer layers. Betelgeuse's ejections are linked to its convective motion, while the Sun's involve magnetized plasma from its corona. Despite similarities in material ejection, their causes stem from differing internal structures and processes. Betelgeuse is believed to be merely 10 million years old, a mere fraction of our Sun's age and making it 50 times younger. Despite its youth, Betelgeuse has already depleted the hydrogen fuel in its core. As a result, it finds itself in the latter stages of its existence, transitioning into the red giant phase. During this stage, it utilizes helium to produce carbon through fusion processes. Betelgeuse's rapid evolutionary journey can be attributed to its initial substantial mass at birth. As noted by scientists, Betelgeuse originated as a blue-white O-type star, which belongs to the most massive category of hydrogen-burning main-sequence stars. In the realm of stars, size equates to brilliance and intense heat. This means larger stars shine brighter and burn hotter. However, it also correlates with faster hydrogen consumption and an earlier transition to the red giant phase. The surface of Betelgeuse could have experienced staggering temperatures of up to 89,500 degrees Fahrenheit, a stark contrast to the Sun's comparatively lukewarm temperature of 10,000 degrees Fahrenheit. The disparity is truly monumental. According to NASA, once Betelgeuse used its hydrogen and started fusing helium, its outer layer expanded significantly from its original size. Nowadays, Betelgeuse is one of the largest stars we know, stretching more than 700 million miles in diameter. However, it's no longer as scorching as it once was. Its surface temperature is around 5,800 degrees Fahrenheit, which is cooler than the Sun. Despite this, Betelgeuse outshines the Sun by a staggering 7,500 to 14,000 times. In 1836, the astronomer and mathematician Sir John Herschel observed fluctuations in Betelgeuse's brightness. However, he might not have been the initial observer. Betelgeuse is now categorized as a semi-regular variable star, displaying periodic changes in brightness and occasional irregular fluctuations. It typically follows a 400-day cycle and a more extended approximately 5-year cycle. However, 2019 witnessed an anomaly in its behavior. What happened to Betelgeuse? In the past few years, Betelgeuse's conduct has attracted significant attention due to its increasingly unpredictable behavior. Throughout history, astronomers have noted the star's regular oscillation in luminosity, following a consistent 400-day pattern. It would brighten to a magnitude of 0.3 and subsequently dim to around 0.8. The cause of the fluctuations have been associated with an outer layer of the star called the photosphere. There is a visible part of this star known as the photosphere. This photosphere of Betelgeuse is where most of its light and heat are emitted. It shows convective motion, where heat is transported from the star's interior to its surface through moving gases. This causes variations in brightness as cooler gas sinks and hotter gas rises, affecting the star's appearance over time. During the autumn of 2019, Betelgeuse significantly decreased luminosity, deviating from its usual pattern of brightening and fading. In a matter of months, the star dimmed by approximately 60%, marking an occurrence now recognized as the Great Dimming. This event made the star 2.5 times fainter than any previous observations. The cause was later determined to be a massive ejection of material from the star's interior, forming an extensive dust cloud obscuring our direct view. While the dust cloud has dispersed and Betelgeuse has returned to its typical brightness, the star hasn't fully reverted to its previous state. Interestingly, its 400-day brightness cycle has now shortened to just 200 days. Betelgeuse's unpredictable behavior sparked discussions about the possibility of an imminent supernova explosion. In case you are wondering what a supernova explosion means, imagine this cosmic drama. As the star consumes its remaining fuel, its core will eventually collapse, giving rise to a black hole while simultaneously expelling the star's outer layers at speeds reaching an astonishing 25,000 miles per second. This grand spectacle is known as a supernova explosion. When it occurs in the case of Betelgeuse, it will offer a breathtaking display for Earth's observers. Given its proximity of just 650 light-years, the ejected layers of gas and dust will gleam as brightly as the full moon in our sky, visible for several weeks. Certainly, this would be an exhilarating event for those who enjoy observing the night sky. The last time a neighboring star underwent a supernova was in 1604. While star explosions are a common phenomenon throughout the universe, most are situated too far away to be seen without the aid of high-powered telescopes. Supernova explosions serve as the grand finale for extremely massive stars. When these stars exhaust their core's helium, red giants initiate the process of converting carbon and oxygen into neon and magnesium, which in turn transforms into silicon through burning. As the stars progress, their cores become filled with iron. This iron accumulation in their cores triggers a supernova. Supernova 1987A, witnessed in 1987 and located around 168,000 light-years away, remains the most recent supernova visible to the naked eye. This event provided valuable insights into stellar evolution. Earlier in 1604, Johannes Kepler recorded the last observable supernova before that. It occurred about 20,000 light-years away and outshone all other stars in the sky, even visible during the day. However, there's no evidence of these supernovas having significant effects on Earth due to their considerable distances. Miguel Montage, a Betelgeuse expert, said that when the supernova moment arrives, the star's brilliance will be intense and vie with that of the full moon, but with a captivating twist. Take a moment to picture a staggering 2-month span during which, on a clear night in the nighttime of an unlit city, with not a single cloud in sight, you could sit down and read a book, basking in the glow of the supernova. When will Betelgeuse explode as a supernova? Similar to the significant dimming event of Betelgeuse in 2019, another comparable event took place in 2021 for similar reasons. Just as Betelgeuse experienced a dimming of around 60%, this phenomenon was also attributed to the presence of a cloud. Stars such as Betelgeuse are in a constant process of expelling gas and dust. This led to the formation of a sizable gas clump within the star's wind, effectively concealing half of the star. Notably, images of Betelgeuse displayed a missing southern hemisphere, indicating that certain stars, similar to Betelgeuse, undergo weather-like occurrences. With that noted, following the 2021 dimming event of the prominent star, it experienced an abrupt 50% increase in brightness. The exact cause behind this sudden surge in brightness remains unknown. It's possible that the intense brightening is a result of the same dust cloud responsible for the dimming, now reflecting the star's light towards us and creating the appearance of increased brightness. However, certainty remains elusive, and this uncertainty has piqued the interest of astronomers. Betelgeuse, currently boasting a size 15 to 20 times that of the Sun, falls within a category of stars predicted to undergo a supernova. The red hue of Betelgeuse points to its classification as a red supergiant, an indicator that its stellar journey is gradually drawing to a close end. But pay apt attention to this. Astronomers generally propose that Betelgeuse could undergo a supernova within the next 100,000 years, which is considered soon in cosmic terms rather than human ones. However, a recent study published on June 1st in the Arxiv has gained attention. In this study, Hideyuki Sayo and colleagues from Tohoku University, Japan, suggest that the star might be in a more advanced stage of its evolution and closer to exploding than previously believed. Nevertheless, there are differing opinions on the validity of this conclusion. Sayo's assertion is based on the star's pulsating behavior. The star experiences instability, regularly expanding and contracting in a pattern with overlapping overtones. Monitoring its brightness over the past century, scientists have documented variations at intervals of 2,200 days, 420 days, 230 days, and 185 days. Sayo's team isn't suggesting that Betelgeuse will go supernova tomorrow or even in the coming decade. They assert that the star could explode within the next 1,000 years, as opposed to the longer timescales of 10,000 or 100,000 years. However, other scientists have argued that stars like Betelgeuse can endure for more than 10 million years. A surprisingly short span for astronomers, but an astonishingly lengthy duration for those outside the cosmic realm. In addition, astronomers have looked for another hint to guess if the bright star might become a supernova. They watch the star's color change. In really old writings, people describe the star's color as similar to Saturn's yellowish shade, not Mars's reddish hue. This makes them wonder, did the star's color change? If it did, it might mean the star is evolving quickly, suggesting a supernova might happen sooner than expected. This color shift gives us a clue about the star's changes, helping scientists puzzle what's happening in the sky. Whether it undergoes this explosion in due time or takes time to give a stellar show and intensify its final act, humanity will be at a front-row view to witness the testament of breathtaking diversity. What would happen if the Betelgeuse went supernova, S7, S8? The idea of a supernova appearing in Earth's sky captured people's imagination. Now, new simulations are helping astronomers better understand what we'll see when Betelgeuse eventually explodes, which is expected in the next 100,000 years, although nothing is certain. Betelgeuse is situated approximately 500 light-years distant. According to recent collaborative research, a significant star must be within roughly 150 light-years to cause noticeable effects. It's believed that such an event occurred around 2.6 million years ago, potentially playing a role in an extinction event that impacted marine megafauna after the Pliocene era. However, things could get dicey if a supernova decided to pop off in our cosmic neighborhood, closer than 30 light-years. Although Betelgeuse's supernova is not projected to directly threaten life on Earth, there could be certain atmospheric impacts. The explosion would emit a surge of ultraviolet radiation, potentially leading to a temporary reduction in the ozone layer. Nonetheless, research indicates that any resulting ozone depletion would likely be minor and brief, with limited environmental implications. Right after the explosion, we'd notice a bunch of weightless particles called neutrinos. Luckily, these neutrinos wouldn't harm us in any way. Following that, the star would rapidly become brighter. Within 1 or 2 weeks, its luminosity would reach a level akin to the full moon's radiance. Afterward, Betelgeuse's brilliance would wane over several months. Still, its presence would grace our daylight hours for about 6 months to a full year. As night descends, it would continue to be a visible spectacle for another 1 to 2 years before bidding us a final farewell. Sadly, Orion would forever lose its red sparkle, a twinkle etched into memory. What threat does this pose to humans? Supernovas release powerful particles known as cosmic rays, which can penetrate Earth's magnetic shield. However, except for the closest supernovas, the amounts would be relatively minor compared to other radiation we encounter. A supernova's explosive finale wouldn't just dazzle us, it would also produce radioactive iron, a cosmic calling card unearthed in Earth's ocean floor and even graced the moon. This iron, born from a supernova blast around 2 to 3 million years ago, was a mere 300 light-years from us, closer than Betelgeuse. Fortunately, its distance posed no major threat to life on Earth. Rest assured, such a nearby stellar explosion is a rarity, possibly occurring only once in a billion years. Amidst speculation regarding the appearance of a Betelgeuse supernova from our planet, Andy Howell, an astronomer from the University of California, was uncomfortable with the mere back-of-the-envelope calculations. To discover the true extent of the expected spectacle, he sought the professional assistance of 2 UCSB graduate students, Jared Goldberg and Evan Bauer. These brilliant minds conjured up intricate simulations that vividly portray the star's epic finale. Meanwhile, they acknowledged residual uncertainties about the supernova's unfolding drama. They managed to enhance their precision by leveraging insights generated from observations of supernova 1987A. This celestial event is the nearest recorded instance of a star's explosive demise in recent centuries. These astronomers concluded that life on Earth would remain unscathed, yet this cosmic spectacle won't slip by unnoticed. Based on Goldberg and Bauer's discoveries, the moment Betelgeuse ignites in a dazzling display, its radiance will resemble the gentle glow of a half-moon shining approximately 9 times fainter than the brilliance of a full moon. This mesmerizing radiance is projected to grace the skies for an astonishing period of more than 3 months. Recent studies indicate that Betelgeuse is positioned roughly 724 light-years away from us, securely outside the potential danger zone. Nevertheless, the supernova could introduce some intriguing consequences for Earth. For instance, Howell highlights that numerous animals rely on the moon for navigation and are disoriented by artificial lights. The addition of a second object shining as brightly as the moon has the potential to cause disruptions in their behavior. It's not just the animal kingdom that would experience a stir. Amusingly, astronomers themselves would find their job quite tricky. Howell remarked, "Astronomical observations are already a puzzle during the moon's brilliance. The concept of dark time would be hard to come by for a considerable period." Diving into the study of Betelgeuse would pose an extraordinary challenge. Its intense brightness would outshine our tools, leading to cosmic competition. He also added that the best telescopes and space observatories would be overshadowed. So, to tackle this, telescopes would have to change their game plan, learning to capture the subtler, softer glow instead. Experts have reassured the public that there will be enough forewarning if Betelgeuse defies expectations and goes supernova during our lifetimes. Earth's instruments would pick up on signals like neutrinos or gravitational waves produced by the explosion, giving us a heads-up as much as a day before the event. As we discussed earlier, this event will not likely happen for another 100,000 years. But what's for sure is that Betelgeuse will eventually turn into a supernova. It could become a neutron star or a black hole at that point. The outcome of this cosmic performance depends on the materials that remain after the grand finale of the supernova extravaganza. Thanks for watching. Don't miss this video you see on your screen right now. You will definitely enjoy it.